determine the identity of an atom. Why are atomic masses not? Use it, Science Notebook 3, How Atoms Differ. Chemistry for You. You are probably aware that numbers are used every day to identify people and objects. For example, people can be identified by their social security numbers and computers by their IP addresses. Atoms and nuclei are also identified by numbers. Review vocabulary. Periodic table. A chart that organizes all known elements into a grid of horizontal rows, periods, and vertical columns, groups or families, arranged by increasing atomic number. New vocabulary. Atomic number. Isotope. Mass number. Atomic mass unit. AMU. Atomic mass. Main idea. The number of protons and the mass number define the type of atom. Essential questions. How is the atomic number used to determine the identity of an atom? Why are atomic masses not whole numbers? Given the mass number and atomic number, how are the number of electrons, protons, and neutrons in an atom calculated? Atomic number. As shown in the periodic table of the elements inside the back cover of this textbook, there are more than 110 different elements. What makes an atom of one element different from an atom of another element? Not long after Rutherford's gold foil experiment, English scientist Henry Moseley, 1887 to 1915, discovered that atoms of each element contain a unique positive charge in their nuclei. Thus, the number of protons identifies it as an atom of a particular element. The number of protons in an atom is the atomic number. The information in the periodic table for hydrogen is shown in Figure 15. The number 1 above the symbol for hydrogen, H, is the number of protons, or atomic number. Moving across the table to the right, next is helium, He. It has 2 protons in its nucleus, and thus it has an atomic number of 2. The next row begins with lithium, Li, atomic number 3, followed by beryllium, Be, atomic number 4, and so on. The periodic table is organized left to right and top to bottom by increasing atomic number. Because all atoms are neutral, the number of protons and electrons in an atom must be equal. Thus, once you know the atomic number of an element, you know the number of protons and the number of electrons an atom of that element contains. For example, an atom of lithium, atomic number 3, contains 3 protons and 3 electrons. Atomic number. Atomic number equals number of protons equals number of electrons. The atomic number of an atom equals its number of protons and its number of electrons. Figure 15. In the periodic table, each element is represented by its chemical name, atomic number, chemical symbol, and average atomic mass. Determine the number of protons and the number of electrons in an atom of gold.
Okay, so we found out yesterday, we were talking about this tile. Remember, element tile. We talked about the element tile on how the name, the atomic number, the AMU is on there, right? We talked about that yesterday. But now what they've told us is that the atomic number is going to equal the number of protons and the number of electrons of an atom. So let's talk about an atom. What does an atom look like? Looks like Jimmy Neutron, right? Because everybody loves Jimmy Neutron. They love drawing Jimmy Neutron for that. So if we're looking, what we have is we have a center. That center is called the nucleus. Inside the nucleus is where we have protons, neutrons, and then our electrons go on the outside of the atom. Okay? Please make sure you drew that in your book. We just learned that they just told us that the proton and the electron is going to be equal to the atomic number. Is everybody good so far? Okay, we're going to turn the page. And what we're going to do is on the next page, there is some questions. We're going to do these together. I'm going to move this up a little bit so we can actually see it. Okay, so if we look, sorry, let me move this. If we look at this, it's giving us our element and our atomic number. And then we got to find out protons or electrons or element or atomic number. So what do we need on our desk?
Calculator.
A calculator would be good. What else would be good?
Yes.
And a periodic table. I'll help you out. So get your periodic table out. Draw this chart in your ISM book. What did you get done? Can I have it, please, sir? Do you have my paper too? Thank you. Thank you, sweetheart. Okay, are you drawing this in your ISN? Troy, I'm going to give this back to you. And you put the correct answer so you can have credit. All right, sir. So whatever I have written down there, you write it on there, and you should have credit for correct answers. Okay, so I'll give it back to you in a few minutes. I forget. Okay, so we're looking at it. Or do you have your table, Jerome? Do I need to wait a minute? I'm going to come by and look. You're drawing this table in your ISN with your ISN book open. Right there. Drawing the table from where we are at this. Yep, you're drawing that in there. Then you get in your ISN book. I think that's what you're used to. I put yours in the box. Sorry, guys, I forgot to say where I put it. Okay, so what we're going to do is we're going to try to figure out what goes inside here. So PB, the easiest way to find PB is look at the atomic number. Remember, the atomic number goes all the way across. So we look and find 82. Have you found 82? What is PB? What symbol is it? Lead. Thank you so much, baby. God bless you. Lead. Okay. So, how many protons and how many electrons do I have? Well, it said the atomic number equals protons and electrons. So, what I got? 82 on both. Is everybody good so far? Does everybody understand what I'm doing? Okay. The next one, tells us protons is 8. If protons are 8, what's the number of electrons and atomic number am I going to put here? 8, because we know they all equal. Okay? How are we going to find out what element it is? Yep, what's number 8? Oxygen. And I'm going to write O because it's only asking for the symbol, right? So then the next one tells me it's 30. If there's 30 electrons, how many protons in atomic number is it? 30. 30 and 30. I look on my periodic table.
Please pardon the interruption.
Yep, it is zinc. And it
At
is
this
Z
time, the
N.
National Honor Society, all students that have been and will be inducted, please report to the mini gym.
I'm going to give you a couple minutes to write that down. So here's what I want you to understand. The atomic number, protons, and electrons are all the same number in an ideal atom. So if you have either protons, either you have electrons, or you have the atomic number, you can find it on the periodic table. Is everybody good? So that's what that whole page is telling us. So now what I want you to do is I want you to go down and try to do number 12, 13, and 14 by yourself. I'm going back up. 12, 13, and 14 in your book. Write it in your ISM book, please. We are on page 116, ma'am. We did this exercise. If you'll copy that on your paper, I put the notes on the board for you. Okay. Yeah. Aaron, please turn on the page that we're at. The answers are on the board, and then the notes are on both sides. Please copy those. And then we are doing 12, 13, and 14 in the book, ma'am. So recap on what we've talked about is we first of all talked about an atom. An atom had a nucleus, which was the center. We have inside the nucleus, we have protons and neutrons. On the outside, we do have electrons. Also, we also decided and found out today that atomic number is equal to protons and electrons. So what we were doing is we were trying to figure out what the missing boxes were. We went through and found them. And now we are doing question number 12. All right, guys, you ready? Question number 12. It says, how many protons and electrons for each one? Radon. All right, where's radon on our paper? What number is it? It's in group 18, and it's going to be in period number 6. What atomic number is it?
86.
86. Thank you very much. So based on that, we know we have 86 electrons, right? And 86 protons for radium. And that's Rn. The next one asks us for magnesium.
12.
Okay, so magnesium is number 12. So there's 12 protons and 12 electrons. Everybody good so far? I know I'm going fast. Number 13. An atom of an element containing 66 electrons. What element is it? 66 electrons And that is dy, right? Okay, so let's write dy because it asked us for the element. Dy. Number 14 asks us an atom with an element with 14 protons. And that is Si. Anybody have any questions? Protons and electrons are the same number.
They're always going to be the atomic number, right?
It's always going to be the atomic number for an ideal element, correct? It's going to change because of something, but we're not talking about that yet. Not always so. Next page.
Isotopes and mass number. Dalton was incorrect about atoms being indivisible and in stating that all atoms of an element are identical. All atoms of an element have the same number of protons and electrons, but the number of neutrons might differ. For example, there are 3 types of potassium atoms that occur naturally. All 3 types contain 19 protons and 19 electrons. However, one type of potassium atom contains 20 neutrons, another 21 neutrons, and still another 22 neutrons. Atoms with the same number of protons but different numbers of neutrons are called isotopes. Mass of isotopes. Isotopes containing more neutrons have a greater mass. In spite of these differences, isotopes of an atom have the same chemical behavior. As you will read later in this textbook, chemical behavior is determined only by the number of electrons an atom has. Isotope notation. Each isotope of an element is identified with a number called the mass number. The mass number is the sum of the atomic number, or number of protons and neutrons in the nucleus. Mass number. Mass number equals atomic number plus number of neutrons. The mass number of an atom is the sum of its atomic number and its number of neutrons. For example, copper has 2 isotopes. The isotope with 29 protons and 34 neutrons has a mass number of 63. 29 plus 34 equals 63, and is called copper 63, also written 63Cu or Cu63. The isotope with 29 protons and 36 neutrons is called copper 65. Chemists often write out isotopes using a notation involving the chemical symbol, atomic number, and mass number, as shown in Figure 16. Natural abundance of isotopes. In nature, most elements are found as mixtures of isotopes. Usually, no matter where a sample of an element is obtained, the relative abundance of each isotope is constant. For example, in a banana, 93.26% of the potassium atoms have 20 neutrons, 6.73% have 22 neutrons, and 0.01% have 21 neutrons. In another banana, or in a different source of potassium, the percentage composition of the potassium isotopes will still be the same. The 3 potassium isotopes are summarized in Figure 17. Figure 16. Cu is the chemical symbol for copper. Copper, which was used to make this Chinese gong, is composed of 69.2% copper 63 and 30.8% copper 65. Figure 17. Potassium has 3 naturally occurring isotopes, potassium 39, potassium 40, and potassium 41. List the number of protons, neutrons, and electrons in each potassium isotope.
All right, go ahead and close your book. Put it on the dividing wall, please. Grab some scissors, please. Grab some scissors. Grab some scissors. Grab some scissors. Grab some scissors. Sir? I want to make sure you understand I am recording. I have been since I started. I do it every day. I'm going to put you on.
Please pardon interruption. At this time, Senior Beta, please report to the meeting gym.
Okay. So what I would like you to do is I would like you to get your 8-man by itself, just the first page I gave you. Okay, I need you to cut it out, so I want to explain to you how this works. You're going to cut this top all the way around. Does everybody understand? All right, go ahead. You should be done when I'm done. Yeah, well, I took the difficult scissors so I'd slow down. Is everybody done? Wad your paper up into a ball. Get up and take your scissors, put it in the box in the back, and put your paper in the trash. Okay. So on our paper, we have ape and we have man. Okay. So I'm going to write the words we're going to put on here first. So atomic number. That's what you're going to put in the very first block. Write the word atomic number equals protons equal electrons.
Please pardon interruption. At this time, High School Student Council and FBLA, please report to the meeting gym.
On the right-hand side, we're going to do mass number minus atomic number equals neutrons. Mass number, correct. Minus atomic number equals neutrons. So far today, we have learned what an atom is, that protons and neutrons are in the middle. Electrons are out the outside. The protons and neutrons are inside the nucleus. We also found out today that the mass number is going to be, like it says here, mass number minus atomic number equals neutrons. We also learned that the atomic number is protons and electrons. Okay? Using the 8-man is the easiest way to do it. The way the book has it is kind of confusing. So what I want to do is I want us to practice this. So underneath the page that you have here, you have a handout that says 8-man. You see it. So we're practicing 8-man. Everybody good? So the first one says, what of the two components make up the atomic mass number? What's the two things that make up the atomic mass number?
Protons and electrons.
The atomic mass number.
The atomic number of neutrons.
Neutron and the proton. Right? The nucleus is the mass, right? It's okay, it's confusing. So the first one asks you the two components of atomic mass number is the neutron and the proton. So write neutron, proton. And if you need to do that, just remember what is inside the nucleus here is going to be our mass number. So I can put on here that my mass number equals proton plus neutron. When I say mass number, I also mean AMU, which is the atomic mass unit. Everybody good so far? Okay. What two components of the atom will be the same number, but only in a neutral atom? What two things are always going to be the same? Proton and electron. So let's write down proton and electron. Is the element symbol always the first letter of the element? Look at your periodic table.
Because potassium, like
Potassium is K,
yeah.
right? That's not a P. What other thing do you see that does not have the letter that it starts with?
Na is like calcium, right?
Is sodium. Correct.
That's
So it is different also. You're exactly right. So let's write both of those down. So I wrote down K for potassium, Na for sodium.
Gold like AU.
Yep, gold is Au.
Silver AU.
Yep. So the answer to that is no, correct? No, because of K being potassium, Na being sodium, and Ag being silver.
K is static.
Correct. So there are elements on the periodic table that do not start with this first letter.
Why are they different letters than what the name is?
The person that found them named them and assigned the letter.
Well, the name changed or something.
Excuse me?
Some of their names changed.
Nope. They decided they wanted to use that letter. Yes, it is. All right. Is everybody ready for the next one? Number 4. Explain the components of the box on the periodic table and what it represents in the picture. Note that it says the explain, not label. Use the element argon. Okay. Are we ready? So on our periodic table for argon, what is on the top of argon? Well, we got ARGON, right? So let's write it. ARGON, which is the, as you said, the name, correct? Underneath argon is what?
18.
18. What is 18?
The atomic number.
The atomic number. All right. And then underneath there is AR.
FSA, first and second.
What does that
semester,
stand
please report
for?
to the mini gym.
The symbol. I have no idea. And then we've got on the bottom is 39.95, right? And what is that?
That is the atomic.
AMU, which is the atomic mass unit or the atomic mass number.
We're talking about the 39 point.
39.95, correct. The next question says, explain the parts of an atom and then draw the diagram representing the atom. That's right here, right? Okay, let's go. So you want to drive the nucleus, which is inside. I'm going to actually put in protons and electrons, and neutrons. So protons have a positive charge. These are protons. What charge does a neutron have?
Negative.
A positive and a negative charge. They have both.
And electrons have negative, right?
And then the electrons have a negative charge. We have to go back in the book in a few minutes. Just remembered. I'll put it on the board and you can do it. Everybody good so far? So you're drawing the atom that's right there. So you've got the nucleus. Inside the nucleus, you have your protons and your neutrons. Outside of the nucleus, you have the electrons on orbitals. Everybody good? All right. Explain the difference between a neutral atom and an isotope. Okay. Here is a neutral atom. How do I know it's neutral?
Because it's got the atomic number and.
Well, let's see. Cu, it says that the atomic number 63. Where's it on here?
Cu is in group 11.
29.
So, the atomic number is on the bottom. Okay? If we look at mine, that's in my book, or in my folder here, I got 63.55, right? Now, I personally, for using this one here, I would have 64. Do you know where I got 64 from? The AMU. Now, if I have an isotope would still be Cu. It still would be 29, but it might be 65. This is an isotope for copper. Now, what's the difference between the two of them? One has one more neutron in the center. Because when we say mass number, that's protons plus neutrons, right? So if that's true, then 65 minus 29 is what? Use your calculator that's on your desk. 65 minus 29 is what? Do you see the calculator on your desk? You got to pick it up. There you go. 65 minus 29, what is that? 36. So that's what that's telling me is there's 36 neutrons in here protons and electrons are how many?
29.
29. Okay, so let's go over here.
So the neutrons are equal to the protons and electrons added together.
Right? 8 men. 29 minus 64. What is that? Huh? 25? 35. So I have 35 electrons here. And how many protons and neutrons do I have? No. How many protons and neutrons did I have? 29. No, it's okay. Listen, we're going to spend a couple of days here. Okay? Because protons, neutrons, and electrons are hard. But can I tell you, the more you practice with 8 men, the better off you're going to be. So what are we going to write down for an isotope? So I say let's write down the example that we have on the board. So let's go. So an example of an isotope is 64 over 29 Cu. 65 over 29 Cu. I would put protons, neutrons, and electrons beside each one. And I would write down what I have. 29, 36, 29. 29. I did that wrong. Sorry. Okay. So the only thing that's different is an isotope is the mass number is different. Which makes it an isotope. We're not going to answer the difference between a neutral atom and an ion yet. Flip over your paper. I want you to take your paper and I want you to get up. And this is what else that's it. Just get up, and I need you also to take your periodic basic paper too, please. Take them both. If you did not get it yesterday, go back to that back table. It's back there. Come on over here. Each one of you get in front of the board. In front of your periodic table, please. I'm going to move this out of the way.